Hello, welcome to the Blind 75 series. So today we are going to solve the first question, name two sum. Okay, so let's not waste any time and let's get into the question. Given an array of integers, nums, and an integer target, return indices of two numbers such that they add up to the target. Okay, so we are given an array. So let's say the array is 4, 5, 1, 2, and 5. Okay, so the indexes are 0, 1, 2, 3, 4. Okay, so this is the array we have. Now we need to find two indices. Okay, two indices such that the element present at both the indices add up to the target. Okay, you may assume that each input would have exactly one solution and you may not use the same element twice. Okay, so question says we need to find two elements present at, let's say, ith index and jth index. Okay, and we need to return both the index I and j. So two conditions which we have to fulfill is, just a second, let me write it down clearly. Condition 1 is I is not equal to j. First condition. Second condition, let's say this array is A, then A of I plus A of j is equal to target. Okay, so with this array, we are also given a target. Okay, so the let's say the target is 10. So we need to find two index such that the index I is not equal to index j and the element present at index I, A of I plus the element present at index j, that is A of j, is equal to target. Okay. Once we will fulfill both the conditions, we have our answer. Okay. So we are going to solve this question with two approaches. First, the brute force and then the optimized. So first look into the brute force approach. Okay. All right. Let me erase this first quickly. All right. So in the brute force approach, we will take two pointers. Okay, let's say the pointer I is currently pointing at index 0 and there is a pointer j which is pointing at index I. Okay, so it means both I and j are pointing at 0. Okay, now if I and j are pointing at 0, it means I is 0, j is 0. A of I is what? 4. A of j is what? 4. Okay, is this I and j fulfills both the condition? It doesn't fulfill this condition, so our I and j cannot be 0 and 0. Okay, so we will move forward. So we will just increment our j. We will keep our I at the same place and we will just increment our j. So now our j is pointing at 1. Okay, so again let's check for both the conditions. I is not equal to j, correct, because I is 0 and j is 1, so I is not equal to j. So first condition is fulfilled. Let's talk about the second condition. A of I plus A of j is equals to target. A of I is 4, A of j is 5, which is equals to 9, and it is not equal to target. It means it doesn't fulfill the second condition. So this I and j cannot be our answer, right? Okay, if this cannot be our answer, we will just increment our j. So just increment the j. Now, again check for both the conditions. I is not equal to j. Yes, I is 0, j is 2. So I is not equal to j. The second condition is A of I, that is 4, plus A of j, that is 1, which is equals to 5. And this 5 is still not equal to 10. Again, both the conditions are not fulfilled. What we will do? We will increment our j. Right, we will just increment the j. So now j is pointing at 3. Again, we will check for both the conditions. I is not equal to j, correct. A of I, that is 4. A of j, that is 2. The sum of both the elements is what? 6, which is not equal to 10. So again, second condition is not fulfilled. So we will again increment our j. Right, so now j will point here. Now again check for both the conditions. I is not equal to j, correct. A of I plus A of j is equal to target. No, it is not, because A of I is what, 4, A of j is what, 5. So 4 plus 5 is not equal to 10. Again, both the conditions are not fulfilled. So we will increment our j. Right? J have expired. Okay, j have exhausted. So now in this case, what will we do? We will increment our I. Okay. So it is just what I'm doing here. I'm just, you can say in coding terms, there's a for loop, and inside that for loop, there's one more for loop. Okay. This is what I'm doing here. So now I have incremented I, and again, j will be initialized equal to I. Okay. Check for both the conditions now. I is not equal to j, but I is equal to j. So the condition is not fulfilled. We'll move forward. J will be incremented. I is not equal to j. Correct. First condition is fulfilled. A of I plus A of j is equal to target. No, it is not. 5 plus 1 is not equal to target, right? So increment the j. Let me erase this first. Yeah. Increment j. I is pointing at 5. J is pointing at 2. Sorry, I is pointing at 1. J is pointing at 3. But the element is 5 and 2. And 5 plus 2 is 7, not 10. Again, we still don't have our answer, right? So we will increment the j, right? So now j is pointing at 5. Now we have our answer. How? Let's see. I is pointing at 1. J is pointing at 4. So I is not equal to j. Correct. First condition is fulfilled. Second condition is what? A of I plus A of j is equal to target. A of I is what? 5. A of j is what? 5, which is equal to 10, and it is same as the target. Okay. Both the conditions are fulfilled. We can end our code now, and we have our solution, that is 1, 4. We will return 1, 4 in an array. All right. So this is our brute force approach. Okay, let's talk about the time complexity. Let's see what I'm doing here. Just a second. Let me erase this first. All right, let's talk about the time complexity. First, my I was at 0. And for I equals to 0, I have initialized the j, which is currently pointing at I. And then this j was incremented somehow. Again incremented, again incremented, again incremented. Let's say we still don't find our answer. So what we did, we incremented our I now, right? We incremented our I, and j was again initialized, which is equals to I. And again, then j was incremented again, then incremented again, then incremented again. And similarly, what will happen? Again, I will increment it, again j will initialize, j will increment it again. So we can see for every I, I am taking another variable j, and for that I, j is iterating over the whole array, right? So you can say the time complexity is n square, because the only way we can achieve this is by a for loop, and there is another for loop inside that for loop. So a nested for loop, right? So yeah, that's why the time complexity is n square. Okay, so the time complexity is what? N square. The space complexity is constant. Why? Because we didn't took any space, right? We are just using the array which was given to us by the question. Okay, so none extra space taken. So that's why the complexity is constant. Okay, so that's all about our brute force approach. Now we are going to see the optimized approach. Okay, so let's start with the optimized approach. For the optimized approach, we will need a hash map. So let me create a hash map on the side. So let's say this is my map. Just a note. At first, you will find the solution a little bit tough to understand. But please bear with me, because with every iteration, the solution will get more clear and clear. Okay. So yeah. Okay. So how the algorithm goes is like, I will create a j variable. Let's say a j pointer, which is pointing at 0 currently. Okay. If my j is pointing at 0, it means this element is my jth element. Okay. Now, if this is my jth element and I want my ith element plus jth element is equal to the target, which is 10. correct? Okay, and my jth element is what? 4. So I now want to find a ith element such that the ith element plus 4 is equals to 10. So what should be my ith element? It should be 6, because 6 plus 4 is 10. Okay, so I will look for the 6 in my hash map. Okay, let me repeat it again. This 4 is my jth element. Okay, and ith element plus jth element is equals to 10, and my jth element is 4. So I want to look for 6, that is my ith element, in my hash map. Okay, all right. So I will look for the 6 in my hash map, but my hash map is currently empty, right? It means there is no 6 in my hash map. So this 4 cannot be my jth element. Okay, okay. If you are having problem to understand this solution, like, please bear with me, because with every iteration it will get easier and easier. Okay, don't worry. So yeah, let's move forward. If this j cannot be my jth element, what will I do? I will just increment my j. Okay, let me erase this first. I will increment my j, but before that, before incrementing my j, I will push this 4 in my map. I will push this 4 in my map. Why? So that this 4 can be ith element for some jth element in the future. Okay, so I will push this 4 in my map. So the key will be 4, the value will be the index at which this 4 is present. Okay, now I will increment j. So let me increment j. Now j is pointing at 5. Now I will consider this as my jth element. Okay, so ith element plus this 5, which is my jth element, should be equal to 10. Okay, so what should be the ith element? It should be 5, because 5 plus 5 is 10. So now I will look for this 5 in the map. Okay, so yeah, that's how the algorithm goes. We take the jth element and we look for the ith element in the hash map. Okay, but we do not have any 5 in our hash map. We only have 4, and 5 plus 4 can be 9, not 10, right? It means this 5 cannot be a jth element. Okay, all right. So if this cannot be a jth element, now we will do 2 steps. First step is push this 5 into the map. So we will push a key 5 with a value 1, which is the index for this 5, and then we will increment the j. Okay, j incremented. Now we will consider this element as a jth element. Okay, we will consider this as a jth element. Now if this is my jth element, so now I want an ith element such that the ith element plus the jth element is equals to 10. So now I want 9 here, right? So I will look for 9 in my map. I don't have any 9 in my map. So what will I do? 2 steps. I will push this key 1 corresponding to the value what? 2 in my map, and I will increment the j. Easy, right? I hope now you're trying to get this, like you are getting the solution right now. Okay. Okay, again same steps. Let's consider this as the jth element, that is 2, plus the ith element, okay, which is equals to 10. So my ith element should be 8. I will look for 8 in my map. I don't have any 8 in my map. So again, what will I do? I will push this 2 in my hash map. Okay, so I will put 2 and a value 3 corresponding to the 2, which represent the index, right? And then I will increment j. Now my j points at 5. Okay, so it points at 4 and the value is 5. So the jth value is 5. The ith value will be something, and the sum of both the values should be 10. Okay, so in order to have this side equal to 10, this ith value must be 5, right? Okay, so I need to find 5 in my hash map. but luckily I have 5 in my hash map. Okay, so I have this 5 in my hash map, and what is the index where this 5 is at? It is 1. So I will return 1 comma what? This jth element index, that is 4. So I will return 1 comma 4. That's the whole solution. Okay, that is the whole solution. So if you still have any doubt regarding this solution, don't worry. When we'll try to code it, you will understand it clearly. Okay, no problem. So let's directly jump into the code. Okay, so this is the question, and I'm only going to code the optimized approach. Okay, the brute force approach, you have to code it by yourself. All right. Okay, so first we need a map. Let's create a map of type int comma int. Let's name it MP. Okay, and there is a for loop where j is equals to 0, while j is less than what? Nums dot size j plus plus. Correct. Okay, let me create an array on the side so that will be easier for you to understand. 4 5 1 2 5. Okay, so right now my j is pointing here. Okay, we have a hash map, and hash map is currently empty, right? So for every j, let's say this is 0 1 2 3 4. Okay, for every j, what will I do? I have to find what should be my ith element, right? How can I find that? I can write something like int ith is equals to target minus nums of j. Correct. This should be my ith element, and then I will look for this ith element in my map. So I will check whether this ith element present in my map or not. If map.find ith is not equal to map.end. Okay, so if this ith element is present in my map, what will I do? I will simply return an array, right, with two values, the ith index and the jth index. Okay, what is my jth index? Simple j, right? What is my ith index? Map of ith. This is my ith index. I will simply return this. Okay, if it is not the ith solution, okay, if it is not present in our map, what will I do? I will push this value. Let's say this for this 4, for this 4, this is my jth value, right? So my ith value should be 6. Then only 6 plus 4 can be 10, right? So I will look for this 6 in my map. If this 6 is not present in my map, what I have to do? I have to do two things. I have to push this 4 in my map, and then I have to increment j, right? So I will push this 4 into my map. So I will simply write map of nums of j is equals to j. Okay, and yeah, at the end we will just simply return -1 comma -1. Why we are returning this? Because there should be a return statement at the end of the function. There should be a return statement, and if I will not write this, it will give me an error. But don't worry, we will never going to reach this statement, because the question says there will always be a solution. Okay, so we will somehow get to this return statement. Okay, so yeah, let's submit this code. Let me shut myself. Okay, let me run this. Okay, we're getting a compilation error. Expected. Okay, sorry, this will be something like this. Okay, all right, and here also. Okay, it is getting accepted. Let's submit it. Yeah, it is getting submitted. All right. So now let's talk about the time complexity. Okay, let's talk about the time complexity. So the time complexity of brute force approach was n square, right? And the space complexity was constant, right? But here the space complexity is O of n. Let's write here. The space complexity is O of n. Why? Because we are using a map. Okay, we are using a map, and in the map there can be at most n elements, right? There can be at most n elements. So that's why the space complexity is O of n, and the time complexity is what? It is also O of n. Why? Because we are running through the loop. We are iterating over this array. That's why the space complexity is O of n, because the space complexity of this find method and this put method, or whatever you can say, like inserting elements in the map, is constant. Okay. So yeah, the time complexity is linear. The space complexity is also linear of the optimized approach. Okay. So yeah, that's it for this video. I hope you found the solution interesting. Okay. So yeah, thank you for watching and keep coding in the next video drops.